Hello, everybody. I should say hi. So Emma was supposed to speak here initially, and she said to me that I should say this all to you. She wanted to speak about Gatsby and React. So if you have any questions or you want to reach out to her, feel free. And to kick the whole thing off, the next 30 minutes, I want to tell you the journey of this person on the web. And I was one of these people that had a tech-savvy father. So I had internet when Google was not yet a thing. What did you do then? You open the browser, you type something, and you see if you get something back. And we're now in Germany. Was anybody registered here? So that was that was one of the first social networks here. It was before StudiVZ, which was a Facebook clone. So 1999, this is where I'm from. There's nothing there. I found myself chatting to people from Berlin, mainly about music, because people where I was coming from were not sharing my taste in music. And this was for the first time when I figured out that the web connects people. So and then I moved to Berlin, and I became a sound engineer, so I fulfilled the dream, worked for the TV, for several TV channels. Then I figured out that working for TV is not well paid, and you work a lot. So then 2010, something happened. I became a web developer, right? Still am. And then the whole statement that the web connects people actually changed, because everybody in this room has a certain superpower. We can connect people. The stuff we build can change someone's world. We enable people. And we help people depending on the products that we build. And I'm Stefan. These are the socks that I bought. I'm wearing these. 3 pairs of dog socks and avocados. And hey, I'm Stefan, and I want to be a responsible developer. So let's have a look at the global population. So there I was, 1999. And now we have 2019, and we could now have a look at some global internet statistics. I'm not the biggest fan of this, but let's do this. So where are the most internet users are coming from today? They're coming from China, from India, and the United States. So this is now global internet stats, right? But what does that have? Why is that important to me? So I also blog a little bit. And when I look at Google Analytics, for example, only last month, I had 300 people from Brazil reading my articles. Think of this. I'm very excited about this. 100 people from Vietnam wrote my stuff, and 80 people from South Africa. I think this is very close to superpowers, right? I just deploy something, and people somewhere in the world read that. But at the end, it really doesn't matter, because we as web developers should be building for everybody. And when I started building for the web, I heard this sentence so often, because responsive web design was just about to come up. We don't have users in a certain region of the world. We don't have users that use a certain device. What happens when you say this sentence? Basically, what happens is that you're creating a chicken and egg problem. Guess what? When you're not building for a certain kind of user, this user won't use your stuff. And it's as easy as that. Building for the web is very hard these days, though. So you have to consider several things. So you have to consider design. 2 years ago at RuhrJS, I learned from Paul, talking about Booking.com's date picker, that red and green are, the meaning of red and green is inverted in Asian countries. Was that right? I learned that then. You made it into my slide deck. You have to consider good content. You have to make it fast around the world. You have to make it accessible, because certain people have different needs to consume your content. Then we're at a JavaScript conference. You have to figure out what to use in the first place. You have to optimize the network stack. And you have to make it work across phones, tablets, computers, watches, fridges. And in the next 25 minutes, I want to talk about the network stack. So let's talk about HTTP. When you request a resource, just typing something in your browser will send a set of key value pairs called request headers to the server. The server will then respond with another set of key value pairs, response headers, and then with the actual resource. So we're dealing with request headers and response headers, key value pairs. And a few months ago, it was very trendy to buy a .dev domain. So I bought a .dev domain. So you see here the responsible.dev. It has JavaScript disabled right now. So let's have a look at what problems are in this site. So I do a refresh. OK. So we see here there's a permission dialog. There are some unicorns from somewhere popping up. And I can also go to CodePen, and I can frame this site, and I can pretend to be the responsible dev. So how can we use only headers to make this site better? And to kick the whole thing off, I have to say that the web is a very, very scary place. A year ago, hundreds of sites were mining cryptocurrency without the people knowing about this. Think about this. Your mother is browsing the web and is cryptocurrency mining for someone else. I think that's very scary. And the reason for that was some third party was hacked. And the thing about this is that when we're building for the web today, we always rely on others. It's never just our stuff. And I believe that the web has to be safe. And the foundation of a safe internet is HTTPS, making a request from a browser to a server in a secure way. By using HTTPS, you can avoid having man-in-the-middle attack. When you're talking to security people, it takes them just a few minutes to open up a public Wi-Fi. And when you browse then via HTTP, they will sniff the heck out of the stuff that you do. A person knowing what they are doing needs a few minutes to do this. Also, browser vendors are slowly pushing towards HTTPS by allowing only cutting-edge features over a secure connection. And I, in my little front-end hipster bubble, thought that HTTPS is a standard. But then you can go to a site like this. Why no HTTPS? It's not 100% up to date, but we're in Germany, right? The ARD is not shipping HTTPS. When you go to ard.de in a public internet cafe, you cannot be sure that this is actually the right content. So what do you do when you enabled HTTPS? Then you have kind of the challenge to ensure that you have a secure secured connection all the time. So what you can do is you can set a response header that is called strict transport security. And what you can do is you can define in seconds that this connection or this domain should only be accessible via HTTPS. You can say, OK, include subdomains, please. And you can set something that is called a preload directive. When you define a preload directive, what you can do is you can go to this beautiful website. You can submit your URL. And what then eventually could happen is that your website or your URL makes it into this JSON file. This JSON file is based in the Chromium source, and it defines just a long list of URLs that should only work over HTTPS. Did you ever wonder why your local domains like mysite.dev don't work over HTTP anymore? .dev is included in this JSON file, and this JSON file is propagated across browser vendors. It's not only about security, though. What happens when you type something into the address bar and you're in a spotty Deutsche Bahn connection? Well, you make an HTTP request first, and it takes 3 seconds for the server just to say, thank you, but you have to go HTTPS. This is 4 seconds that you just have to wait. When you say, hey, always be secure, you can save these 5 seconds. So how's the support for HSTS, or strict transport security? It's pretty green. You can use that today. And depending on your project, you then have to kind of upgrade all the HTTP requests. So how can you do this? What you could do is you could set a CSP, Content Security Policy Header. And you could say, OK, upgrade and secure request. This is a response header. And with this, all the resources that go HTTP magically go HTTPS. I think that's super cool. But this is not actually what CSP is for. CSP is for limiting what is allowed in your website. You can really nail down what resources should be loaded and from where should they be loaded. And there's stuff like, where should style sheets coming from? Where should scripts be coming from? And there are also some cutting-edge things. So you can define CSP in a meta element in your HTML, or you deploy it and you ship a header like this person. So this is the CSP header for my private website. And what you usually do is you deploy it because you think you have an idea of all the resources in your website. You break your site, you roll back, because the resources that are not whitelisted here won't happen. The browser will just say, nope, you didn't allow this. So the way that you usually would do this is you would deploy this header. It's a content security policy report only header. And what this allows you is that you can slowly work on this list of resources that are allowed in your site. And then you can define a URI that accepts these logs. And then you can step by step say, yeah, this should be loaded, no, this shouldn't be blocked. And after a few weeks, when you feel like all your logs are safe, then you can finally turn it on and start blocking real stuff. If you know CSP and you look at this list, you may already say, Stefan, you're not very secure, because I'm shipping these two things, unsafe inline and unsafe evil. So this basically allows inline JavaScript. The reason for that is that I'm using a hipster JavaScript framework, and it inlines some JavaScript, and it doesn't have the CSP support. So I'm working a little bit on this. So how would you allow inline JavaScript in your HTML pages? There are two ways. You can define a hashed value in the script source. This now has the downside that when you deploy a little bit different JavaScript, that you have to update this. Depending on your infrastructure, updating a header, depending on script sources, is maybe not the easiest thing to do. Or you give an ID, a so-called nonce property. With this, you can whitelist certain scripts inside of your HTML. So also support for CSP today. CSP is there in two levels. Level 1, you can use that. Certain properties of level 2 are a little bit jumpy still, but when the browser doesn't understand them, the browser doesn't understand them. That's it. So maybe you know about HTTP Archive. This is this project that crawls the internet, and then you can write queries against the crawled sites. So what do you think how many pages actually use this to avoid people mining cryptocurrency? Any guesses? Of 3 million crawled pages, 6% use CSP. And I think that we can do better. This is the reason why hundreds of sites were mining crypto. So when you want to start using CSP, always monitor first with the report only, and then slowly start enforcing it. So when we go to the responsible.dev and we go to the /safe, you see that the unicorn hacker is not able to inject unicorns. It looks very red, but this is good because the browser is preventing stuff from being executed. And also I'm disallowing framing using CSP so that a person cannot just code pen my stuff and pretend to be me. And I think kind of actions like this are crucial for people. But it's not only about security. I hang out on Twitter quite a little bit, and more I see these statements. Your stuff doesn't work in Africa. All right, but I hear you say, yeah, but Stefan, what should I care about Africa? It's like, it's also me when I travel around Europe. This is my mobile provider, O2. When I got out of the plane, this was in the Ukraine, I get this message, and let's just read this for a second. It's, you get 6 megabytes for €2, but you have to use it in 24 hours. The average website today is 2.5 meg. This is very kind, right? And telling me that I have to use it. This takes 2 minutes. Which means that for me, the web has to be affordable. And one thing of an affordable web is not making the same request over and over again. And caching is one of the hardest things in computer science, so I will only briefly touch it. What you can do is you can set a cache control header, and this basically tells the browser, hey, here's the resource, please cache it for that amount of time, and use it when it's there. Just because you define this header doesn't necessarily mean, though, that the browser is not double-checking. Like, hey, I have this resource, is it still fresh or not? This happens in certain cases. What you can do is you can set an immutable directive, because very often for things like assets, we have something like styles.hash.css. There's no need to revalidate this file, because if it changes, it's a different file. So just enabling the immutable directive, you can save a lot of requests. And for big players like, for example, Facebook, this made a big, big difference. So what's the support for immutable? We're getting there, but you can just deploy this. And if it makes some things a little bit faster, I think that it's already worth it. If you want to dig into the whole caching topic, Harry Roberts wrote a massive article about this, because caching is hard. So if you want to learn more, you can read about it there. But it's not only about saving requests, it's also about sending the right data in the first place. So when you make an initial HTML call, the browser sends this header, accept encoding. And what you see there is gzip, deflate, and br. These are compression algorithms. So let's have a look. I took a normal style file with 100K. I compressed it with gzip, which brought it down to 15K. And then I compressed it with Broadly, which brought it down to 10K. And you may now say, Stefan, come on, you're over-optimizing, right? 6 or 5K, what's going on? Last week, Wikipedia deployed a JavaScript change. They saved 9K in their JavaScript bundle, which now results in 1.4 terabytes saved data on the wire. This stuff makes a difference. So when we look at these kind of things, you may say, okay, Stefan, I had a look at Broadly, but Broadly compression is so slow, which is basically comparing apples with oranges. So let's have a look. So gzip by default has 9 compression levels. Broadly has 11. The default mode of Broadly is level 6, which was picked for speed and maximum file sizes. The Broadly default mode was 11, which was picked for maximum file sizes. This is why on-the-fly compression with Broadly is a little bit slower. The thing with this is, though, when you tweak Broadly to not run in the default mode, it tends to compress better than gzip. This is why you can go, for example, to Cloudflare, and you can enable Broadly compression by just ticking a box, because it's as fast as gzip, but it compresses better. And in the end, you don't have to compress it maybe on the fly. We are all running build processes these days. What if we just compress all the assets in the most compressed way and then ship them statically? If you want to learn more about Broadly, you can check this. This article is a little bit older, but it's very nice research if you want to learn more about Broadly compression. So how's the support of Broadly today? We're also there. And when you have a look at what the big players are shipping, Facebook is shipping Broadly, Dropbox is shipping Broadly, because a few kilobytes make a difference for them. So it's also about the compression, but it's also about tailored media. And responsive images are now there for quite a little bit. So maybe you're guilty of writing an element like this. So what this does, it does a feature detection check for WebP, which is an image format by Google. It's usually a little bit smaller. And it does responsive images. But guess what? When the browser requests an image, it also sends this request header. It tells the server, hey, I understand these image formats. And how's the support for WebP today? Well, WebP is not supported in the Apple universe yet, but I think that the peer pressure is pretty high now. And what you can do then additionally is you can define a server header that is called accept.ch, which stands for client hint. And this is actually super cool, because now you can say, hey, browser, please tell me about your viewport width and the image width for the next 100 seconds. What happens now? This is an image request, right? And you see like, hey, this image is that big now. You've got this information in headers, which then means you can have an image element without anything responsive images except the sizes attribute. And now you get the following information. You got the accept header, which tells, hey, I understand these formats. You've got the viewport width and width of the image. This also takes responsive images and high-density images into consideration. And with this, now you can serve tailored media using a service worker or React on the server with this. Client hints are a little bit cutting edge, so you cannot use them tomorrow. But if you want to learn more about them, because I'm very excited about them, Jeremy Wagner gives a lot of talks about this. And then there's also this header, save data, which looks like this. This is a browser header, so a request header. You can define that by going very deep into the browser settings, which is a bummer because it's very hidden everywhere. And then you could potentially serve experiences to the users that don't need 2.5 meg, but maybe 500K. And when you look, for example, at Twitter, Twitter ships this. They have a safe data mode. And now I'm entering slightly rant mode. So are you ready? And they're not using the safe data mode. They're going away from the standard. And I'm really asking, why are we not building browsers like this? Why is not safe data next to the URL bar? Why is it close or very buried in browser settings? We should provide an easy way to opt out expensive stuff all the time. And while we're at it, who sees dark interfaces right now? Developers, because they can go into operating system settings to say, I want dark interfaces. Does your partner know when he or she is sitting in bed how to enable dark interface? I bet not. Who sees reduced motion in websites right now? Nobody, except developers. See? Because nobody knows. But reduced motion is not only about accessibility, it's also about me with my MacBook on an AirPod with 5% battery. I don't need your animation. All these settings should be easily accessible all the time. Speaking about safe data, though, you have to be careful because Google plays the Google game. So when you turn on safe data in the mobile Chrome, it could be that Google proxies the stuff because they think that they can make the web faster than you can. And maybe they're right. But I'm not sure how I feel about the whole proxy stuff because they pretend to be you. If you don't want to be proxied by Google with safe data, you can set a no transfer directive and tell Google, no, I want to be myself. So, and I think safe data is very fascinating because when you look, for example, at Shopify, Shopify has a lot of traffic. And we see there that they're shipping 13% less data when people have that enabled. And now look at this, 20% of their requests have safe data enabled. This is not a setting that is easily to enable. And I think these people really want less data. And this doesn't necessarily mean that you have to ship a lesser experience, right? Maybe you can just drop the carousel nobody cares about. Maybe you can drop the font nobody cares about. Maybe you can load fewer images. People have safe data on for a reason. So when we go to responsible dev/affordable, you see that I'm first of all shipping broadly, which saves some bytes on the wire. And then you have this image element, which requests JPEG, but I'm serving WebP, because the header tells me that the browser understands WebP. And now look at the size of the image element. The request includes the width of the image, which means that I can serve different images depending on the viewport width without any markup changes. I think that's very, very cool. So with this, we can save some data on the wire, and I think this is important because the web is with us every day. And unfortunately, we're slowly messing it up because the state of the web is like this. I'm guilty of building at least parts of this. Not the whole story, but... And I think this is the wrong approach because the web has to be respectful. We are building for people out there. And one of the biggest things about respect is probably respecting people's time, because that's something we can never have enough of. So how can we respect people's time? Tell the browser what resources are needed and kind of reprioritize what is going on. So what you see there is a link element with rel preload. And with this, what you can do is you can tell the browser, hey, this resource, you don't know it yet, but you will need it in 2, 3, 4, 5 seconds. And the browser then can already start requesting this, which then leads to a better user experience. And guess what? You can set it as a header too, which then saves one round trip on the way. Depending on your setup and you use the header, you have to be a little bit careful though, because certain CDNs and proxy servers interpret this header as a HTTP to push statement. And this is not the best idea still, so if you want to talk about HTTP to push, you can grab me later, but you should go no push as of today. This is great to speed up critical resources like fonts, CSS files, or things like that. The support for that is like this today, but you can just use that. If the browser doesn't understand it, it's like that. And then we have the AMP reaction. So AMP stands for Accelerated Mobile Pages. It's this Google thing where Google tries to limit the whole internet by releasing a framework, a JavaScript framework to make the web faster. And when it was released, which was 3.5 years ago, I was giving this talk, which was AMP tries to fix the web. So I went deeply into how AMP works technically, because technically it's very interesting. But when they released it, all the standards people, the people that built the internet were like, this is not good, this is not good. We need a standard for this. We need to limit what people can build in the web. And this is very exciting because now 2.5 years later we have this. We have a feature policy header which allows me as a web developer to say, nope, in my website, nobody should be able to vibrate the phone or ask for geolocation, which is very useful when you're dealing with third-party stuff on your site. And you can define a lot of things. Especially when you're shipping with third parties, this can be very, very useful. We're cutting edge, but we're getting there. And the interesting thing is here, you can deploy on your staging server that you don't want to allow unoptimized or unsized images. How cool is this? You or your QA person or whoever can just go to staging and you can guarantee that your assets are in the right shape. So this is the feature policy header that I ship for my site right now. Unfortunately, you cannot say deny all. So you have to go step by step by step by step. But it is like it is. You can use feature policy for iframes, like this, which is also interesting when you're dealing with third parties. And you have a JavaScript API available that you can then check, am I allowed to ask for geolocation? So I only showed you the complete list very, very briefly. So you might ask yourself, maybe you spotted it, what's the most annoying thing of the web right now? Push notifications. Actually, it's not that easy to disallow push notifications because they are embedded in several parts of the browser. If you're interested what happens to them, you can check out this GitHub issue. So how's the support for feature policy today? Yeah, but you can deploy that header, right? And if this maybe prevents only one location ask dialog that you didn't want, I think it's already worth it. So when you go to the responsible.dev/respectful, you can see that the permission dialog is gone, which I think is very nice. And you see that there, it looks very red, right? But this is good because I'm preventing stuff from happening. And when you see there, there's this unleashed image, which was loaded on the second place in the waterfall. Instead of, the browser didn't have to wait until it was discovered. So to close, the building for the web is very, very, very hard. You have to consider designs, content, performance, accessibility, frameworks, network devices, and there are probably 25 other parts that I didn't mention here. If you want to get a complete overview of all things headers, you can have a look at this slide deck. It's maintained by my friend Shep. It's called HTTP Headers, the Hidden Champions. And this is a treasure of information. It's very, very good. And Andrew Betts, who works on actually specs, gives this talk that is called Headers for Hackers. So you can just Google this. He gives this talk in several variants. It's very, very useful. So I think that the web has to be safe, because it shouldn't be possible that my mother mines cryptocurrency without knowing it. I think that the web should be affordable, because no matter where someone lives on this planet, information should be accessible and cheap. And I think that the web should be respectful, because nobody likes annoying people on the street, right? We should just be respectful to each other. So the web has to be safe, affordable, and respectful, so that it really is for everybody. And I'm Stefan, and thank you very much.